Hello everyone. It's been a while since we made the last video, but I finally found some time. And today we will be molding a carbon fiber single-bladed propeller for F2A models. Propellers are arguably the most important element of the F2A system. They're converting engine power into thrust, and they operate in a very unique aerodynamic regime. So the propeller aerodynamics is a very interesting area of research. Not only aerodynamics is important, but also the strength of these propellers must be very, very high. This propeller rotates at about 40,000 RPM, usually slightly over 40,000 RPM. And naturally, because of the high centrifugal force, the blade is experiencing stress. So it must be very robust and not break under those loads. So the technique I will be showing you today is nothing new. I think it's been in use since at least the 1980s, and it's been perfected over this period of time by many people making these objects. Let's talk about materials first. We will be molding a propeller out of this carbon fiber. This is a Japanese medium modulus strength, and I will put a description of the materials in the description for the video. We will be impregnating this carbon with epoxy resin. The epoxy I'm using is a laminating epoxy. Air Epoxy is the brand, POR 2032. This is something that's available to me. I would say that any other laminating resin which is liquid enough will work fine for this application. Now let's talk a little bit about molds. So of course, in order to make a propeller shape, you need the mold. And they come in several types. I have three here to show you. The first one, and probably the original type, is the mold that's made of special casting resin. In the past, we would use a conventional epoxy filled with aluminum powder. This one you see is an aluminum box, and then inside of it there is a cavity which is shaped using this special casting resin. So when you close the mold, you create a cavity that has the shape of the propeller that you need. I've been using this epoxy system. It's Epoxy 655. It's a high temperature casting system resin, also available in the United States. The second mold type is a hybrid. So in this case, you see it's made of 4 pieces carved out of aluminum. And the principle is the same. You put these things together and close it, and inside you have a propeller. The difference, of course, is that it's a 4-piece, so it's much more precise in shaping the blade. However, the blade itself is still shaped using the same casting system resin. And finally, the third type, the pinnacle of mold making, is a mold that's carved out of solid piece of aluminum on a CNC machine. This is, of course, the fanciest one and gives you the most precise results. But the principle is the same. This is a 4-piece mold. You put these pieces together like this. You close it, and voila, you have a propeller. Naturally, in order for your propeller not to stick to the mold, you must use some kind of a release agent. In my case, I'm using high-low mold release by Finish Care. This is a wax-based release agent which you apply to the mold using a piece of fabric or something like this. but they come in different types as well. Anything works. Next, we'll lay the fibers on a flat board, which is covered with a mylar film, such that it would not stick. 200, 200, 160, 160, 130, 130, 100, and another piece of some length. Looks like it's about 160 or 170 millimeters. Next, we will be mixing some epoxy. I am usually mixing around 8 to 9 grams. This is too much, but it's okay. Better to have some extra than not have enough for the molding. And now we will stir it, and you can see that this is a really, really very liquid resin. I usually stir it for about a minute, then leave it to sit for a couple of minutes, and then stir it again. All right, the next step is to wet the fibers, which I'm doing by just pouring epoxy sparingly on top of the fibers. And as I told you, I have enough resin, maybe too much, but that's okay. I've used almost all of the 10 grams, but yeah, we will not need all of it. We just need to get the fibers nice and wet. So pour it on, set it aside. Now I'm using a plastic card, a hotel key, and I'm distributing epoxy evenly over the fibers. Not squeezing too much, not squeezing too firmly. I want to get the fibers soaked in epoxy very well. We need to squeeze the excess out, but not too much. We don't want fibers to be completely dry. There needs to be some amount of resin left in the fibers. So now let's put the fibers into the mold. So first I'm putting the longest strand, which goes all the way along the blade. From the very tip then it goes around the axis like this, and then back into the blade. Spread it nicely along the blade. Make sure that it goes all the way, because when you close the mold, it will be pushing the fibers around, and we don't want any voids in here. So next, I will put a 160 millimeter piece, starting at about 2/3, maybe 3/4 of the blade length. Same as above, it goes around the axis and then back into the blade, but not all the way to the tip. And finally, the shortest one, 100 millimeter one, which starts about halfway, goes around, and then exits back into the blade. This way, when all of the fibers are wrapped around the axis, you have the most strength, and you can be assured that the blade is not going to fly away under the load. So let's put the second half in. Now we can put the weight, press it in slightly with your fingers. Distribute. And now we need to make sure that the hub is completely filled. So for that, I have enough in here. I'll just cut it in smaller chunks. Very well. And a little bit of resin, it will squeeze out. If we have too much, it will just go out. Okay, now one last look. Make sure that the threads are distributed well and parallel to the blade. And it's time to close. So now, as you can see, the mold is completely closed. All of the nuts are tightened. This resin sets at room temperature for about 24 hours. So I will see you in about a day. Now it's been about 24 hours, but my microphone refused to work on this one. So I'm going to be doing a voice over an existing video. And here I'm going to be showing you a quick trick for unbolting the nuts and bolts from the mold using an electric drill. This really accelerates the process, makes it much quicker. Now, taking the mold apart, first you pull out the axis, and then using a screwdriver you just peel off the pieces. First goes one of the tops, and as you can see, the release agent really worked well. It's not a very difficult procedure, nothing requires a lot of force. Second top comes off in the same manner. And finally, you split the side halves and you have the blank in your hands. Now, with a little bit of magnification, let's look at how it came out. I'm pretty happy with the amount of flashing. As you can see, much of the resin was squeezed out as I predicted, and the flashing isn't too big on the leading edge. On the trailing edge, there's probably a little too much, so I may need to adjust the amount of carbon fiber. Now, cutting off the flashing is accomplished using curved scissors. I'm using scissors with carbide tip jaws. Makes for a quick process, and the scissors then last very long. And finally, a little bit of a zoom in. I am again quite happy with the outcome. The surface finish, the layout of fibers. I think this is going to be a pretty good propeller.